Hi guys, we're in lesson 17.2. This one is all about similar figures. Let's see if we can draw right here. But basically similar polygons. Polygons just means any size of figures, I guess it would be. We're going to specifically be talking about triangles later on, but we're going to start off with just general shapes right here. But polygons with the same shape, so they've got the same shape but different sizes, are what we call similar polygons. So we just kind of enlarged them or shrunk them a little bit, but they've got the same shape. So we can tell that polygons are similar if the corresponding angles are congruent. So the corresponding angles still have to be the exact same measure, congruent right there. However, the corresponding sides, they're not going to be the exact same. They're not going to be congruent here. They're going to be what we call proportional. That's why we did our proportions earlier. So proportional, oops, not sure why we changed colors there. Proportional. And then we have a ratio. Now remember, a ratio is just when you compare two things. It's just one basically. In this one, we're going to compare one side to another side. But the ratio of corresponding sides is called the scale factor. The scale factor goes right here. And then if the polygons are similar, then their sides are also proportional. Okay, so we just basically, you've got to remember this. Similar triangles or similar shapes have congruent angles. So the angles are the exact same measure, but your side lengths are going to be different. They will be proportional, but they're not going to be the same. I'm actually going to, let me kind of illustrate this really quickly. We're going to just draw a triangle since we're going to be actually, let's draw this triangle. Since we're going to be doing triangles here, there's a nice, lovely triangle. Now, my smart board right here lets me clone this. Now, if we're looking at these two triangles are congruent. Notice how they've got the exact same side measures. The angles are the same, everything. These are what we call congruent triangles. That's what we did last lesson. Now, this time we're going to be talking about similar triangles. So they're the same shape, we just make them bigger or smaller. Whoops. And I messed that one up. So we're going to do this. Oh, there we go. We're going to do this again. You just make them bigger or smaller. So I'm going to make this one actually smaller right there. So we'd still say that these are similar. Now look really quickly how cool this is. Your angles still line up. Notice how that those angles are still the exact same. All three of those angles are the exact same right there. But they're just different sides. Or the sides are different sizes. I'm actually going to do one more thing. I'm going to draw my own triangle. So to show you that it could work with any triangle right there. Let's see. Oops. All right, so we're going to group this together right here. Group it, and then we're going to, group. And then we're going to clone this one as well. All right, now we're going to shrink it up here. Again, we've got similar triangles. These are still the same shape. Notice how they look similar here. My side on the left is the smallest. There's still similar triangles, but look right here. Even though the sides are different, those angles are the exact same measure. All right, so that's what I just was trying to point out right there. The scale factor, basically all you're going to do to find the scale factor is you're going to take one side of this and compare it to one side of the other side. And there's a couple ways to write the ratio. A lot of times you see a ratio with the little two dots right in the middle of them. So what I would tell you to do is order matters here. So look at a side here in your ABC triangle. We're just going to take any of these sides right here. If we know that these are similar, it doesn't matter which side. So let's take the smallest right there. Is everyone okay with that? 8 is the smallest. So we're going to put that on the left because our triangle ABC is first. Now DEF, notice it'll kind of tell you which it's proportional to which side. It's between our 1 tick and our 2 ticks. Or I just look at it and say that's the smallest. So it's going to be proportional to the smallest over here, which happens to be 12. All right, so that's one way you could write it is 8 to 12. We just read the 2 dots as 2. I prefer fractions. So I will be using this in the answer key in my work. I'm going to write it as 8 to 12. Remember, the first one goes on the top, and then the second number goes on the bottom. And a lot of times they will simplify this. Okay, so a lot of times they'll simplify this and say, oh, 4 divides into both of these numbers. So we can simplify it by dividing both of them by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So our scale factor is 2/3. Or again, you could write it as 8 to 12 or 2 to 3. And those are perfectly fine too. All right, order matters. So if they're asking the scale factor, it's the exact same question. What's the scale factor? They just mixed up the triangles. They asked D, E, F first. So just remember to write those numbers first. It's going to be 12 this time to 8, or 12 over 8, or 3 over 2 right there. So all of those are the same thing. Now, please note, if you used other sides of your triangle, you'd get the same thing. So say I used the biggest number instead of the smallest number. Okay, so if I use the biggest number, I've got 21 to 14. Well, those will both divide by 3 as well. Or sorry, those divide by 7. Then you get a 3 to 2. So they'll give you the same ratio. It doesn't matter which side you use any side. That'll also go with the ratio of the perimeter. Go ahead and add them all up, but I guarantee it's going to be this exact same measure right there. The perimeter is going to have the same scale factor as any of the sides do. It'll just be 2, oops, and sorry. And I messed up there because I didn't look at the order. Notice right here, they asked for the bigger triangle to the smaller triangle. So this one's going to be your 3 to 2 right here. Let's go ahead though and add these all up. If you add, let's add 12 plus 14 plus 21. 12 plus 14 plus 21. You get 47 over 8 plus 14 plus 10. 8 plus 14 plus 10. You get 32. Let's do this one more time. Oh, I did 14 instead of 15. So 12 plus 15 plus 21. And that gives you 48, not 47. They're both divisible by 16. If you divide them by 16, you've got 3 right here, and 32 divided by 16 is 3/2. So that scale factor, again, it doesn't matter which side you use. Just watch the order. Okay, the first one to the second one. Okay, last thing in this video really quickly is how you write a similarity statement. Actually, we're going to, how am I going to do this? Sorry, guys. We need the other copy. We need to come back here to this page. And we're going to group these together. And we're just going to make it a little bit smaller here so that we can paste. Where's my paste? The statement down here. Okay. All right, we're still learning with this new software. But a valid similarity statement, when we talk about similar, this is the sign. It's just one squiggle. Remember last time when we had the congruent, our congruent had a squiggle with 2 equal signs. That means that they are the same measure. These just say that they're similar. So they're not going to be equal. They're just proportionate. So you will just say, if you're talking about triangles being similar, go ahead and just name this anything you want. ABC, since it's a boring in alphabetical order. Okay, so triangle ABC is similar to triangle, and then you're going to need to just match up the angles. Notice that angle A with that 1 tick is congruent to angle D. So D's got to go first. Angle B and angle E both have 2 tick marks, and then angle C and angle F are congruent. So that's how you're going to write the similarity statement. All right, we'll do the examples in our next video.